Well, hello there. It says I'm live, so I'll take YouTube's word for it. It's Mike Levin on Wednesday, March 11th, 2020. And I am here today to talk about the genesis of an SEO project I'm working on. Think through it from a database point of view, data-centric point of view. Even though we are probably not going to use a database. So anyway, step one, I have recently powered on my system. You can see I have a few things running already. I would like to start these videos out completely fresh without this stuff running. And ironically, I had to actually run something I deliberately put off till step 2 first in order to get that live streaming software running. So that's a browser-based thing, so I need the browser running. And because I always run the browser by running Jupyter first, in this case Jupyter Lab, it is on screen 2 and already opened up and ready to go on today's project, which I will nickname Surveyor. The nickname becomes the name of a directory, which becomes the name of a GitHub repo, and starts to frame everything in your mind about the project. The importance of a nickname is so great, and it's important to establish it right at the beginning. So at any rate, step number 1 usually is, instead of running that first, I run this first. I have Control-Alt-T that launches it, but it is the Windows terminal, which is a Linux terminal, which is on my system as a result of WSL, the Windows Subsystem for Linux 2, version 2, which will be released very shortly to the public. This is taking a moment to appear because I had actually restarted my system not long before this video, and that was a complete Linux boot. It doesn't let you show the stuff scrolling past, it just sort of jumps to the login screen. But this takes advantage of some virtualization hardware technology, stuff that's already in these Intel chips called Hyper-V or Hypervisor. And it can get a lightweight virtual machine running really quick, helping manage the resources between different operating systems that are running on the same hardware. So neither starves the other, and that they are kind of like equal citizens on the machine. So when I have a system that looks like this, with a Linux terminal full screen on screen 1, it's not, particularly starving the system for resources the way virtual machines of ages past did. I have the web browser on screen 2, and on screen 3 we put, in this case, because I'm going to be thinking through concepts, I'm going to put ArtRage. It's like a $50 paint package that's available on all different platforms, including Android and iOS. So you can have ArtRage pretty much everywhere you are. You have to pay for it on each platform. It's a lot cheaper on mobile, like $5 or something. But it starts to take care of the muscle memory issue. I am a big believer in not doing things that you can't over time master and commit better and better to muscle memory. And so all of this pen writing stuff is one, but we know how to draw. We just need to keep all this stuff going around it, how to choose your different writing points, how to make them larger or smaller, how to undo unintentional drawings, change your colors. So this is pretty much all we need to think things through conceptually. So we are going to think it through in an auditory fashion here first and jump between the different screens based on whether we need to think it, try it, or see it. So I jump into my journal, and I do my macro to start a new day's entry, and I go objective. be using I nicknamed this project Surveyor, Surveyer. Be using the Surveyor. Is that right? Because Surveyer, what does Vim spelling think it should be? OR. What did I do here? ER. I don't like that. I am going to rename it right now. Let's see. Should be right click. But those are the browser right click options. Probably if we go up to that higher level, and then we choose it here. Oh, and right click it here. Rename, there's my rename. So one of the things I'm doing now is getting familiar with Jupyter Lab. I was a Jupyter Notebook person for a while, and now there's this sort of little crisis that I'm working through. Should I be on VS Code or not? And those things that I'm seeing about VS Code, I'm like, oh, that looks familiar. That looks like how it's done in Jupyter Labs. And I had that thought enough times that I decided I would actually just try to move myself from Jupyter Notebook to Jupyter Lab, from free and open source to free and open source, deeply rooted in the data science world. That is not necessarily people who need to think in terms of visual IDEs and all the things that VS Code can do, but rather can keep things in sort of this easier environment. Dare I say easier, because VS Code is actually easy too. So what is it? Is it that it's more free and open source than VS Code? This is a whole sub-discussion, but I'm trying to keep an open mind, and I do indeed keep VS Code ready to run. However, I'm starting this project out in Surveyor. Surveyor. I still have a difference there, don't I? Surveyor. Sur. This has got to be correct because I'm not getting a spell check warning. So, boy, this must be painful to watch for you guys, but hey, I don't really edit. And this gives me an opportunity to show you what real day-to-day work is. And these decisions, if you make mistakes, you're going to have to live with them. They're going to propagate. And so you want to make sure you have it really how you like it when you set out, because chances are, even though you could change these things, you're not going to. So right off the bat, since we already know we're going to be doing a Jupyter Notebook project or a Jupyter Labs project, and we're in there, we might as well go ahead and create our first IPython notebook, because it's going to be notebook-based rather than .py file-based at first, I believe, because this launcher tab that it always gives you, has this as its opening statement to you in the world. And so the most upper left thing you can choose is an IPython notebook with the default Python install that was active when it started, which is going to be Python 3.7 something, because Jupyter Labs is not quite up to date with the Python organization. But this is a notebook, and the first step here, I keep saying first step, everything is the first step. It's always like 1, 2, 3, step 1. Rename that. Still getting myself used to the post notebook world and into the labs world. So Surveyor, Surveyor.ipython notebook. It's going to be nice to make those two things name the same. But what are we going to do here? It's going to actually be a bit of time before you discover that. I'll maybe show a few things to tie together what I'm about to draw to you. So in computer science, there's this idea of entities and entity relationships. So entities are most frequently drawn as boxes, and there's various labeling conventions, but a different entity would be a different box. And then there's relationships between these entities that are drawn in different ways, usually using some sort of line to connect them. And then, if it's a one-to-one relationship or if it's a one-to-many relationship, how many are allowed to be on the left and the right. And there's these whole languages so that as tables relate to other tables and it goes nested and such, you have an entity relationship diagram, an ERD. And the ERD, in terms that non-database people would appreciate, is it's your basic layout of your rows and columns, mostly your column labels in a Microsoft Excel product or a Google Sheets product. Basically, in spreadsheet terms, each table would be the equivalent of a different tab for the most part. I know people use it differently, but one tab, one table. And then things on one in the table of one tab are somehow VLOOKUPable against things in the table of another tab. And that gets you your approximate relationship between the database world with this idea of drawing with no backing supporting this is not working out well. Maybe it's the broadcast software that I'm using, but I think I'm going to forego this drawing. File new. I'm not proud of that, and I'm doing this live, so best thing to just blank it, and maybe I'll come back and do something visual in a moment, but I certainly think at this point I go back here, and the objective is to be using the Surveyor app. We can think of these things in terms of an app effectively to mine, the web for certain information. And that's all you need to know about that. But it will require us to be doing certain things. The entire endeavor starts at keywords. So these keywords are actually going to belong to some sort of category. So there is the concept of category. There's also the concept of keywords, and their keywords belong to categories. Now, these keywords are going to be used in order to create SERP results, search engine result positions, or SERPs. And those SERPs are going to contain a list of URLs. Okay. And each of these URLs is going to have another URL, which is resolve the landing pages, and we'll talk about that more later. And those URLs are going to have, let's see, how am I going to do this? So, bear with me. Live is interesting because you go to a search engine, you plug in your keywords, you get back your SERPs. Your SERPs contain a whole bunch of URLs, and you change those into a different set of URLs. You sort of expand them. Although that's probably not necessary. I am jumping ahead of myself. Those URLs are going to result in crawls, sites to crawl. There's also going to be a concept of a filter here to restrict what sites end up being crawled. So I don't want to confuse object types and their methods and properties and such here. So the only things I'm trying to really show here are things that functionally act as containers for things that are like what they're named. So URLs contains a bunch of URLs. SERPs actually contains a bunch of entire result sets from HTTP requests. This has the URLs from them extracted out, and once you have those URLs, there's some logic that steps in and says, here are the sites that you want to visit. So it could use the URLs thing directly as the same type of object, and I might not have to go any further than that. And in fact, once you have those URLs, it's just going to result in more URLs, but there's a container object concept. Everything that you find is contained to the home page or the domain of one of the URLs that you started out with. Now, you want to start out with the URLs you discover because you want to go to the pages that are actually discovered, but once you're there, a crawl expands it, creates a piece of crawl data for each of the URL that's allowed to be crawled. So I'm going to stick with that. I like that thinking. Resolved URLs is almost, the crawl data, it's almost like crawl data. It's URLs too. No, I'll go with URLs too. This is good thinking. My gut reaction. It's there's a URL table there, but there's a resolved URLs table here. And from those resolved URLs, we do further categorizing, which is almost always external table stuff. Okay. So I've got some good data types to work with here. A little bit of uncertainty between this and this, but they're both really the concept of URLs. Let me call it what it is. After the crawl, we have resolved URLs, okay? And I'll keep it a separate object type. That's a definite architectural decision to keep it a separate object type, because I could have turned around and tried to shove it back into this object and then used properties to keep the two types different. But I think I want to be able to simplify the app by having only one type of thing I find in one type of place I look. Okay, so now that we have thought through something that is approximately equal to the concept of tables in SQL or tabs in Excel, we now are going to think of it in terms of named tuples in Python. It's a strange one, okay? So this is where playing around with Jupyter Lab is really going to come into play, because it really lets us demonstrate in a nice fashion these different data types that we have to work with. And I can just quickly check here against the data type we're really going to start out with, which is keywords. So let me choose a simple keyword. I guess for the sake of being a little bit meta, we'll say Python tutorial. But I'm going to show a nice old trick. If you want a list of things in Python, you can do the triple quotes, and then you can put your list in just a stacked thing here. Python tutorial, Linux on Windows, right? Two things that I probably will get known for over time. So you can split that on the line return, which \n stands for, and you can see that will turn it into a list. but it has the beginning and end because this counts as a line and this counts as a line. So you simply say from 1 to -1. And I turn on the light on my keyboard. And we execute that. And there, you see that? It's just the two items. So now we can say keywords equals, and now we've got a variable named keywords here. And so we have the basis for sort of starting out in our work. Now, when I feed the keyword to some sort of function, I'm going to come back with a SERP, or a search result. And the thing to know there is that let's see, what more than just the keyword might I want to keep track of? This is going to be a simple one because I could probably use the simplest case before even using a named tuple. We're going to show the simplest example of using a dictionary instead. So first most common use case is a simple dict, or a dictionary. In Python. Now you already see a list. A list is these things that have these square brackets around it. So you could do for, an arbitrary word in keywords and do something like print the word, right? So this is almost like a hello world kind of thing. You create a list, you show the list in its string representation, which shows it with the square brackets around it. You iterate through the list and do something with each member of the list. To confirm that it is in fact a list, we can type keywords, and it'll tell you, oh, that is a list type. And you can even check whether things are of a certain type. So you can do equals list, true. And at this point, for a given keyword, we're going to have some sort of a function, probably called serps. So let's say def serps, and it gets fed a word. And then it returns something, and it almost doesn't matter what it is in this case, but we'll use an empty list as a representation of what it returns. Now actually that is a bad example because lists are dynamic in nature, and using them on if either function definitions or return values is as a default thing has ambiguities I would like to avoid. So I'm going to return a tuple. And if we were to go serp, anything, doesn't matter, serps, plural, without messing up my parentheses, it returns that empty tuple. Okay, so we have a situation now where I'll have it return the word inside the tuple, so at least it passes something through, right? That's interesting. I think it's unpacking the tuple, or else it would show the parentheses around it. Some interesting things about Python going on here. If I return it as just a word, it should show the same thing. Okay, so I'll do it that way. It'll just be a pass-through so that we can have a value. Maybe I'll do it times itself. Times 5. So it's 5 occurrences of that word. So it at least does something to it. So it looks like data other than what it went into it. And so now we were talking about a dictionary. So say we wanted to put that as the result for each keyword. You need a way to associate each keyword in the list with some output of the function. Knowing that these keywords are unique, which is not actually even determined yet. One thing we could do here is ensure uniqueness by saying this is a set. Set. It doesn't like that. Set object has no split. So you can split a list, but you can't split a set. That's fine. After the split. Okay, so now it is in curly brackets instead of a traditional list, and that means it's ensuring uniqueness. And if you were to look at the type of it, you would see that it is not a list anymore, but rather is a set. And you can do all the same things as far as iterating through with a set as you can with a list. However, it has ensured the uniqueness, and since it is ensured uniqueness, you can know that for every member of your set, you can use it as a key in a dictionary, because unique. So a loop like this is how we traditionally fill, that's not the loop, this is the loop. A loop like this is how we traditionally fill a dictionary with the output of a function for each member of a list or a set. So we'll give it a name. We already have used SERPs, so this can be results. Results equals, we can use shorthand notation for a dictionary, which is like that. And instead of printing the word, we can say that results using for its input or for its key the word. So results dictionary with a key named word. In fact, how can you resist using key there? Because it's for key and keywords, right? Results key equals the output of the SERPs function. Keyword in there. Now things are a little bit out of order here, and probably we should have the use of a function underneath of the function definition. So, if we were to run it all in order, it would come out well. In fact, for clarity's sake, one of the best things to do is to restart and clear all outputs. It gets everything that might have been in memory out of memory, and makes things quite a bit easier to look at. Now there's also a merging cells feature here, which is one of the major selling points on labs versus notebooks, which we'll be using soon, but I'll run them one at a time just for our edification. And we don't need this one anymore. I'm going to cut that. But we now have a results object, which we can look at directly, and we will see the Python string representation of the output of that function. So you put Python tutorial in as the key, you get Python tutorial times 5 out as the output, and it's stored in this dictionary. So you've got this dictionary now that you could put arbitrary objects in there. Just to make that point, it's arbitrary objects. I can return arbitrary objects. Right. So this is how we're going to get search results against a list of keywords and ensure that we're not doing it over and over. Now, in fact, to make sure we're not doing it over and over, assuming that SERPs is going to be doing a fair amount of work here, we actually want to check to make sure that the results are not already in results, or else it's doing a wasted run of the function. And you can do that here. Now, granted, I'm creating the object in the first place here, so of course it's going to be empty on every new run here. But later on, I'm going to definitely be using persistence, some real database of some sort, to make things a whole lot more efficient. So you can put a check here, if key not in results, and now that won't run it unless it hasn't performed that potentially, expensive SERP lookup. So to put it all together, we can get to this point now by kernel, restart, and run all cells. And if it gets to this okay, it tells you that it has done everything correctly. This is only for our edification, so we can delete that. Now, let's look at a little bit of Jupyter Labs, because one of the advantages here is now we can sort of combine that together into one big script. It's still an IPython notebook, which is different than the way it would be under VS Code. So I'm still not 100% sold that Labs is my next move. Maybe I'll go to VSC. However, I'm trying to avoid a vendor dependency to make this my new text editor and to have another 10 years beholden to Microsoft. Now, I am on Microsoft hardware now. That's only because it happens to be the best hardware out. Microsoft hasn't replaced this laptop I'm on in darn close to 3 years. That's how right they got it. It's just such a perfect one to be on at the moment. But things change, and who knows? I want the freedom to bounce to Mac or maybe a Linux desktop in the future. But however I do it, I always want to have my tools ready to move around. Now, arguably, those tools can move around. VSC is based on the Electron code. It is portable between platforms, which is why I'm not totally writing it off. Maybe a proprietary vendor provided tool is the way to go, but I'm inclined to stick with Labs as my next step after Notebook. I want to get myself on Labs so that I can start using Dask and other tools that have added features if run under this environment. Anyway, I'm starting to babble, but what I want to do is find the way to merge fields. Merge selected cells, Shift-N. Select, merge selected. Let me try Shift-M while I'm just in one cell. Nope. You definitely don't want a blinking cursor. Shift-M while I'm here. Yeah, oh, look at that. You can just Shift-M all the way down. This keywords is unnecessary because that was just to see it. But that is an interesting thing about Jupyter Labs now. My videos are about to become a whole lot more interesting. So, for anyone who's not seeing why this is the genesis of an SEO project, I will just call you to the fact that if I were to replace this function with a function that actually performed that SERP call, which I had actually done in prior videos, this would be populating a dictionary object with the output of that function so that I could step through these and step through those and such. So I'll be getting to that. I think I'll wrap up this video right now. I'm not sure if I'll keep the concept of the video, the genesis of an SEO project, or perhaps an introduction to Jupyter Lab. I think now that I mention it, I maybe should do this one last thing, which is to show off these environment type things that are possible when you keep all your paths super clear. So I'll do a Control-Alt-T to go into my text editor. CD SUR Surveyor LS. There is the single IPython notebook that I had created, and Git init. We turn it into a Git repository. Not GitHub yet, it's only a Git repository. So now if I did an ls, it would still look like just the one file. But if I did an ls-la, you would see the hidden directory that was created there by Git as I turned this into a Git repository. Similarly, IPython Notebook or Jupyter Labs has put this directory here for its checkpoints. And now we can git add surveyor. And so now there's one file added to the Git repo, and now we can git commit added first file. Now, if this were on GitHub, my next step would be to do a git push. You know what? It's easy for me to do. Let me take this the whole way. Sometimes doing the unexpected is a little bit scary in live environments like this, because who knows, right? But I'm going to go to GitHub. I don't think there's any harm in that. It'll drop me directly into my Pipulate repo, which is a public one. And then I can go new repository. The repository name is going to be, don't get that spelling wrong, and I'll make it public. Why not? I'm not going to initialize with a README. I'll just create that repository. This is the magic line we need. We make GitHub the remote origin. And then we need to do one git push that tells it to use the origin master, and after that it can just be git pushes. Go back to GitHub, we do a refresh. There it is, added first file. So this is a repo in GitHub, Mick Levin. I'm Mick Levin here as opposed to Mike Levin, which I am on YouTube, /surveyor. I don't know if I'll be keeping this public, but for this first video, I thought that would be fun. And you can start to see the relationships now that we were thinking through. There can be a keywords table, which turns out it's going to be a set. And then there can be a SERPs table, which is the results that we have created. The SERPs is the equivalent of the results dictionary. And we did in fact call this keywords set. And we haven't addressed these other things, but those are coming up real soon as I start to transpose some of my older projects into this current project to sort of isolate out just the bits I need and give this project its own strong, separate identity from everything else, where it's kind of mixed together with Pipulate a little bit right now. And I'm going to try and extricate them a bit. So that brought us through these two steps, thinking through the more overarching app, and showed you some of the things that have come into play for database-like things, because, you know, what is something that's still sitting there in memory like that, and then a dictionary, a database, right? Want to see results again? There's results again. All I have to do is dump the contents of this object in memory to the hard drive so that I can load it again, which is the pickle library. And I've got myself a database, and there's lots of other ways to turn it into a database than that. You can back-end it with all kinds of things. The Unix DBM system comes to mind, Redis. You can back-end this with Postgres if you want a more traditional row and column RDBMS database. NoSQL, no problem, because this is key value pairs, just like NoSQL specializes in, but you can use traditional RDBMS databases as well to back end this. And I guess the named tuple, since I teased you about that, I think I will at least make this point before I go, which is if you import from collections named tuple, let's see, import named tuple from collections. Yeah, when I do it from scratch, I always get these things mixed up. Anyway, I got it mixed up again. Let's Google that. Import named tuple. They imported the whole collections library. I'm going to try from collections, import named tuple. Okay, so then there's this this pattern where you create this uppercase version of you see how we're using strings, unique strings as keys in a dictionary? All kinds of things can be used as a key in a dictionary so long as it is immutable. And the most immutable informative thing out there is a named tuple. And it's my latest trick for avoiding like object-oriented programming. It's great because you get to create a class of a certain type of object. Let's call it SERP, because we're going to have a single SERP, because singular is the convention for this. A single SERP is equal to named tuple SERP, comma, if I get this right, keyword results. Okay, and then when you run things through a function, you can say a single SERP is equal to SERP, and now it has an API. Foo is your keyword, and bar I'm going to put in as the result. And if you look at SERP, it is now a named tuple. SERP keyword equals foo, result equals bar. And now you can refer to this as things like SERP dot keyword, SERP dot keyword, which is an alternative way to the square brackets. It's a dot object notation. So already things get a little bit easier to type, easier to keep in your mind. When you look at an instance, the values are named with their column names, essentially. These are column names if you're thinking in normal table form. But most importantly, remember that results object that's still sitting around in memory because REPL. Results, these can be used as keys in a dictionary. doesn't matter what that value is. But now if we look at results, now granted it's unusual to look at things that have mixed key types, but if you consistently use a named tuple as your key type, you ensure uniqueness of input parameters, and so your key becomes the input parameter that you know you're going to send to some other function, and your value becomes the output of what you received from that function. And this combines with all the other things like automatic caching systems, so that you have database without database under Python with next to zero of the IT infrastructure effort that's usually put into these types of things. And that's where I think I'll stop there. I think I've delivered what I promised, the genesis of a Python SEO project, and some of the really awesome, unique things about Python, like using a named tuple as a key in a dictionary, which is like a JSON object. So these are your keys and your key value pairs in a JSON object. But because they can be an object like this, it has all kinds of advantages, from readability and explicitness to reproducing processes just by looking at your data and knowing what's supposed to be done with it. It just makes everything so much clearer. It's often said that once you lay out your tables in your SQL or your tables in wherever, you have designed your application, and a smart enough system can come in and just interrogate those tables and figure out what it's supposed to be. Here's a new purchase order form. Here's a new employee record. Just from looking at your tables and the way you named your columns or your fields, whatever terminology you want to use. And a similar thing can happen here very easily in Python, especially so if you used named tuples as the keys in the dictionary. So thanks for joining me. Hope to see you again soon. And if you like this sort of video, really don't forget to subscribe and refer people here, because this is what I do. This is what I do on a daily basis, and I'm not trying to really sell you anything here. This is me wanting to share, to sort of reach out and connect with audience, especially through these interesting times we're in, and to give you something to focus on, to exercise your mind on, that will serve you in ways that will be with you for the rest of your life. Because even when Jupyter Labs goes away, which it inevitably will, you'll still be able to run things in Python. Let's see, echo. Yeah, let's see, let's try print. Hello? This is just a stupid hello.py. See if I'm remembering my things right now. I can't do it because of, oh, well, I can probably put parentheses. This is me just rambling. And there's the output of the hello, right? These sorts of things, you just know how to do stuff that is in a way more fundamental and will always, always be around long after these volatile things about platforms and the way things are in a snapshot of time right now today, they come and go. And your goal here with me is to make yourself resistant to obsolescence by doing things that are 100% applicable in the modern way of doing these things, and 100% timeless. In it will probably still serve you that way many, many years later in your career. So anyway, thanks for joining me. Hope to see you again soon, and don't forget to subscribe.